Our galactic neighborhood, a complete history. In roughly 4.5 billion years, our home, the Milky Way, won't die. It will be reborn. But this rebirth won't be a quiet fading into the eternal night. It's set to be a violent, spectacular, and transformative event, giving rise to something entirely new, a colossal galaxy born from a cosmic collision that has been in motion since the dawn of time. This isn't science fiction. This is our destiny. It's the final chapter in the epic story of our galactic neighborhood, a story of its chaotic past, its dynamic present, and its absolutely breathtaking future. To understand where we're going, we have to first know where we came from. We have to journey back to the very beginning. The cosmic dawn. A neighborhood takes shape. Our story begins not with a bang, but with a whisper. Nearly 13.8 billion years ago, the universe was a formless, searingly hot soup of energy and fundamental particles. There were no stars, no planets, and definitely no galaxies. There was only potential, waiting to be sculpted by the most patient and powerful force in the cosmos, gravity. Just after the Big Bang, the universe went through a wild period of hyperexpansion called inflation, which smoothed out the cosmos on the largest scales. But it wasn't perfectly smooth. Tiny quantum-level fluctuations in density got stretched across the expanding fabric of space-time. These minuscule ripples, areas just a fraction denser than their surroundings, were the seeds of everything that would ever exist. They were the blueprints for the great cosmic web. As the universe expanded and cooled, a mysterious invisible substance we now call dark matter started clumping together in these denser regions. It formed vast invisible scaffolds, or halos, creating gravitational wells that began pulling in the primordial gases, mostly hydrogen and helium. For hundreds of millions of years, the universe was dark. The so-called cosmic dark ages were a time before stars, when the only light was the fading afterglow of the Big Bang, stretched far beyond what the human eye could see. But inside those growing halos of gas and dark matter, the pressure and temperature began to climb. Gravity squeezed the hydrogen and helium relentlessly until, somewhere between 150 and 200 million years after the Big Bang, a miracle happened. The first stars ignited. Now, these weren't like the stars we see today. Known as population 3 stars, they were monsters, hundreds of times more massive than our sun, burning incredibly hot and bright and living short, violent lives. When they died in colossal supernova explosions, they seeded the cosmos with the first heavy elements, providing the raw materials for all future stars and planets. This is the era when our galactic neighborhood, the local group, was born. Picture this patch of space not as it is today, but as a chaotic construction site. Countless small proto-galaxies, shapeless blobs of gas, dust, and the very first stars were forming inside their dark matter halos. These were the celestial bricks and mortar for the grand structures to come. This early period was one of non-stop cosmic violence and assembly. These proto-galaxies were constantly bumping into each other, colliding and merging. It was a gravitational free-for-all, a process where small things came together to build bigger things. Out of this primordial chaos, 3 main players started to emerge in our corner of the universe. 3 proto-galaxies, heftier than the rest, began to throw their gravitational weight around, pulling in and consuming their smaller neighbors. These were the earliest forms of the Andromeda Galaxy, the Milky Way, and the Triangulum Galaxy. They were the gravitational anchors that our entire local group would eventually organize itself around. The formation of Andromeda was likely a dramatic affair, forged from the violent merger of 2 or more big ancestral galaxies very early on. This would explain some of its features today, like its huge, sprawling halo and its history of intense star formation. The Milky Way's origin story seems a bit different. While it certainly grew by gobbling up smaller systems, its main body appears to have formed from the collapse of a single, large, rotating cloud of gas, which then continued to grow by capturing smaller companions over billions of years. It had a more measured, though still pretty rough, youth compared to its bigger sibling. The name local group came much later, coined in 1936 by the legendary astronomer Edwin Hubble. He identified it as a typical small group of nebulae which is isolated in the general field, originally listing just 12 members, including the big three. Hubble realized we weren't just an island in space, but part of a gravitationally bound family. Today we know this family is much, much larger. The local group is a gravitationally bound collection of over 80 known galaxies, spanning a vast region of space roughly 10 million light-years across. It's our cosmic home, a structure held together by the mutual gravity of its members, fighting against the overall expansion of the universe. The gravitational center of this whole structure lies somewhere in the void between its two most massive members, our Milky Way and the Andromeda Galaxy. These two giants, Andromeda and the Milky Way, completely dominate the local group, containing the vast majority of its mass and light. They're like two gravitational superpowers, each with its own sphere of influence and its own system of satellite galaxies orbiting it like planets. The third largest member, the Triangulum Galaxy, is a significant spiral in its own right, though much smaller than the two Titans. The rest of the group is made up of a whole host of dwarf galaxies, small, faint collections of stars that are often hard to spot but hold crucial secrets about how all galaxies, including our own, came to be. This, then, is the family portrait that began to take shape from the fire and chaos of the early universe. A family bound by gravity, defined by conflict, and destined for a future that was already being written into the laws of physics. A dynamic present, the cannibal and the dance. So, what does our neighborhood look like today, billions of years later? The chaotic construction site of the early universe has settled into a dynamic, ever-evolving metropolis of stars. The local group is no longer a collection of shapeless proto-galaxies, but a mature, structured, and incredibly diverse cosmic family. Let's take a quick tour. The group is structured sort of like a dumbbell. On one end, you have the Milky Way and its entourage of satellite galaxies. On the other, about 2.5 million light-years away, is the Andromeda Galaxy with its own court of followers. Together, these two subgroups contain the bulk of the local group's mass, estimated to be somewhere around 2 trillion times the mass of our Sun. Andromeda, also known as Messier 31, is the undisputed queen of the local group. It's larger and more massive than the Milky Way, containing perhaps 1 trillion stars compared to our galaxy's estimated 300 billion. It's the most distant object you can see with your naked eye, a faint, fuzzy patch of light in the autumn sky, a ghostly hint of the Titan next door. Andromeda is surrounded by its own impressive system of satellite galaxies, including the bright, compact galaxy M32 and the elliptical M110, both visible in amateur telescopes. Our Milky Way is the second largest member, a beautiful barred spiral galaxy that we can only ever see from the inside out. Our most famous companions are the Large and Small Magellanic Clouds, two irregular dwarf galaxies that are standout features of the southern hemisphere's night sky. For millennia, people thought they were just detached pieces of the Milky Way, but we now know they are distinct galaxies, orbiting our own and tangled up in a complex gravitational dance. The third major player is the Triangulum Galaxy, or M33. It's a beautiful spiral galaxy, but at about 1/10 the mass of the Milky Way, it's a much smaller system. It might be a satellite of the much larger Andromeda, or an independent member on its own path. Beyond these big three, the local group is overwhelmingly populated by dwarf galaxies. They come in a few flavors: gas-rich dwarf irregulars, like the Magellanic Clouds that are still busy forming new stars, and dwarf spheroidals, which are older, gas-poor, and look like faint, fuzzy balls of stars. Astronomers have noticed a fascinating pattern. The gas-poor dwarf galaxies tend to be found clustered closer to the Milky Way and Andromeda, while the gas-rich dwarfs are usually found further out in the cosmic suburbs. This is no coincidence. It's the smoking gun for one of the most dramatic and ongoing processes in our neighborhood: galactic cannibalism. Galaxies like the Milky Way and Andromeda are not gentle giants, they're cosmic predators. Over billions of years, they've grown to their current size by pulling in and devouring smaller galaxies that stray too close. This process isn't a collision in the way we usually think of it. When a small dwarf galaxy falls toward a large spiral like ours, the immense gravitational forces, known as tidal forces, begin to stretch and pull on it. The smaller galaxy is gradually pulled apart, its stars stripped away into long, graceful arcs known as tidal streams. These stellar streams are like cosmic breadcrumbs, tracing the path of a devoured galaxy as they wrap around the conqueror in a ghostly embrace. The Milky Way's outer halo is crisscrossed with these streams, the shredded remains of dozens of past meals. One of the most famous examples is the Sagittarius dwarf galaxy, which is currently in the process of being torn apart and absorbed by the Milky Way. Its stars are being woven right into the fabric of our own galaxy. Andromeda is an even more voracious cannibal. Studies of its vast stellar halo show evidence of it having consumed numerous smaller galaxies and even one that was quite large. About 2 billion years ago, Andromeda appears to have collided with and absorbed a galaxy that may have been the third largest in the local group at the time. The dense core of that devoured galaxy might still survive today as M32, one of Andromeda's closest companions, a galactic ghost haunting its destroyer. This constant consumption doesn't just add stars to the bigger galaxies. As a dwarf galaxy is stripped apart, its gas can also be stolen in a process called ram pressure stripping, essentially blowing the gas out of the smaller galaxy. This shuts down star formation in the dwarf, turning a once vibrant galaxy into a quiet, gas-poor one. This explains why the dwarf galaxies closest to the Milky Way and Andromeda are the ones that have had their star-forming fuel stolen. They're the victims of cosmic predation. This process of growth and cannibalism defines the dynamic present of our local group. But this ongoing local drama is just the opening act for the main event. While the Milky Way and Andromeda are feasting on their smaller neighbors, they are also performing a gravitational dance with each other. A dance that is drawing them inexorably closer. From observing Andromeda's light, astronomers have known for a century that it is blue-shifted, a telltale sign that it's moving towards us. Based on precise measurements, we know that the Andromeda galaxy is hurtling toward the Milky Way at about 110 kilometers per second. That's nearly 250,000 miles per hour. For a long time, the collision was thought to be a certainty, a head-on cosmic smash-up scheduled for about 4.5 billion years from now. However, the cosmic dance is a little more complex than that. More recent research, factoring in the gravity of other local players like Triangulum and the Magellanic Clouds, suggests there's a chance it could be more of a glancing blow or happen later than we thought. But whether it's a direct hit or a sideswipe, a major interaction is unavoidable. The two largest members of our galactic family are on a collision course. Their huge halos of gas are already beginning to touch and mingle across the 2.5 million light-years that separate them. The first, gentle handshake before a cataclysmic embrace that will reshape our entire galactic neighborhood forever. We are living in this incredible moment where we can use science to piece together this entire cosmic story, from the dawn of time to a future billions of years from now. We can literally see our own destiny approaching in the night sky. If you find this journey through space and time as mind-blowing as I do, consider subscribing. We explore the biggest questions in the universe every week, and by joining our community, you help us continue that exploration. Now, let's brace ourselves and leap into the future to witness the ultimate fate of our galactic neighborhood. The ultimate fate, the birth of Milkomeda. Let's travel forward in time to a future so distant it's almost beyond our grasp. Our destination, 4.5 billion years from now. The sun is still around, though it's growing larger and hotter, slowly making Earth's surface inhospitable. But the real drama is unfolding in the night sky. From the perspective of a hypothetical future observer, the Andromeda galaxy would no longer be a faint, fuzzy smudge. For millions of years, it would have been growing larger and brighter, a majestic spiral dominating the view. By about 3.75 billion years from now, it would fill a huge portion of the sky, its immense gravity starting to visibly warp the familiar band of our own Milky Way. The first pass is about to begin. The two galaxies won't simply crash into each other like solid objects. Galaxies are mostly empty space. The average distance between stars is so immense that direct star-on-star collisions will be incredibly rare. If our Sun were a ping-pong ball in New York, the nearest star, Proxima Centauri, would be a pea in Chicago. Instead, the two galaxies will pass through each other, like two immense clouds of smoke. But the gravitational interaction will be catastrophic for the galaxy's beautiful structures. As they pass through one another, tidal forces of unimaginable power will rip through both. Great streamers of stars, gas, and dust, called tidal tails, will be flung out into intergalactic space, stretching for hundreds of thousands of light years. The elegant spiral arms of both the Milky Way and Andromeda will be torn apart, their delicate patterns twisted into a chaotic, tangled mess. The night sky would be a dizzying storm of light, a sky on fire with stellar streams arcing from horizon to horizon. The immense clouds of gas and dust in both galaxies, the nurseries for new stars, will be violently compressed by the collision. This will trigger a furious burst of star formation, a galactic starburst. The sky will be ablaze with the brilliant blue light of millions of newborn, massive stars and the pinkish glow of vast nebulae. It will be a brief, spectacular era of creation in the middle of all the destruction. After this first violent pass, the two wounded galaxies will move apart, but gravity's leash is unbreakable. They'll slow down, stop, and then inevitably fall back toward each other for a second, and then a third encounter. Each pass will further scramble their structures, their energy bleeding away into the random motions of their stars. Over a period of maybe 2 billion years after the initial encounter, the dance will finally end. The two galaxies will have fully merged, their stars mingling and settling into new randomized orbits. The distinct spiral structures will be gone forever. In their place will be a single, colossal galaxy. Astronomers have playfully nicknamed this future galactic behemoth Milkomeda, or Milkdromeda. Milkomeda will most likely be a giant elliptical galaxy, a vast, football-shaped swarm of stars. Having used up much of their gas in that initial starburst, elliptical galaxies have very little fuel left for new star formation. So, after its brilliant, fiery birth, Milkomeda will eventually become what astronomers call a red and dead galaxy, dominated by older, smaller, redder stars. Its sky will be bright, but it will be the sky of old age, not youthful creation. And what about us? What's the fate of our solar system in all this? While Earth itself will likely be uninhabitable because of the Sun's own evolution, the solar system as a whole will probably survive. The chances of a direct collision with another star are practically zero. However, our position within the galaxy will almost certainly change. We could be flung far out into the new, larger halo, or plunged deep into the chaotic, dense galactic core. Our cosmic address will be completely rewritten. At the heart of this new galaxy, an even more dramatic merger will take place. Both the Milky Way and Andromeda host supermassive black holes at their centers. As the galaxies merge, these two monsters will begin a long orbital dance, spiraling inexorably toward each other. As they get closer, they will unleash enormous amounts of energy in the form of gravitational waves, ripples in the very fabric of space-time. The final merger of these two black holes will create a single, gargantuan black hole with the combined mass of billions of suns. This cataclysmic event could trigger one last powerful flare-up as huge amounts of gas are funneled into the new black hole, potentially creating a quasar that would briefly outshine the entire galaxy. The story of the local group doesn't quite end there, though. Milkomeda will now be the undisputed gravitational monarch of the neighborhood. Over the next tens or even hundreds of billions of years, the remaining galaxies, including Triangulum and all the surviving dwarfs, will one by one be drawn in and absorbed. Eventually, the local group will cease to be a group at all. It will be a single, solitary, massive, elliptical galaxy. And even that may not be the end. Our local group isn't entirely isolated. It sits on the outskirts of a much larger structure, the Virgo supercluster. It's possible that on the very longest of cosmic timescales, our newly formed Milkomeda galaxy will eventually fall into the gravitational grip of the Virgo cluster, becoming just one small part of an even grander cosmic structure. From faint ripples in the moments after the Big Bang to a chaotic swarm of proto-galaxies, from a dynamic, evolving neighborhood shaped by gravitational predation to a spectacular, galaxy-altering collision, and finally, to the birth of a new, colossal galaxy that will slowly consume all of its children. This is the incredible story of our local group, past, present, and future. It's a story written on the grandest of scales, playing out over billions of years. It reminds us that nothing in the universe is permanent. The majestic spiral of the Milky Way, our home, the galaxy that has defined our sky and our place in the cosmos for all of human history, is itself a transient thing. It had a beginning, it has a life, and it will have an end that is also a new beginning. We are so lucky to live at a unique moment in cosmic history, a moment where we can not only look back and piece together the story of our origins, but also look forward and predict the spectacular fate that awaits us. We are inhabitants of one of the great cities of the cosmos, watching from our window as another, even larger city draws ever closer, destined to merge into a single, magnificent megalopolis. We may not be here to witness that final, fiery embrace, but by understanding it, we gain a profound and humbling perspective on our place in this grand, beautiful, and ever-changing universe.